This is the tutorials for the hypergeometric distribution, and this is the general formula, as well as what these variables in general stand for. So pause the video and copy that into your notebook if you don't already have it. The first example is the simplest kind, the kind where your probability is exactly equal to a number. Now, in the hypergeometric, you're needing to get this value, well, let's look at these. Big N is your total number in the population, so all the patients. Your little n is your sample. So in this one, 8 patients are the randomly selected ones to receive the drug. And then this K variable is the number of what we call the successes. So you're looking to your probability to see about your successes. It's asking, what is the probability that exactly 2 will die? So your K value is the total number of patients that could die. Right here it tells us that 8 have a heart problem that could result in death if they take this drug that we're testing. So that's where that variable comes from. Then we're just going to do this calculation one time. So I plugged all those variables into the formula and got that number. Now in this one, it's also exactly equal to 3. So pause the video and copy this stuff down if you're not understanding how to translate this problem into these variables. In this problem, we have that we're looking for the probability when x is less than or equal to 1. The number in our sample is 8. So if we think about finding the probabilities for the x values that are less than or equal to 1, we can see that we're only going to have to find the probability when x equals 1 plus the probability when x equals 2. And that is what I'm doing here. I figured it out for 0. Here it is. Figured it out for 1. Here it is. Then we're adding these two numbers together. In this example, it's also for x is less than or equal to 1. And since our sample size is so small, in this problem, it really doesn't matter which way you do this. Probably the preferred way would just be to match this probability. So we would just calculate for the probability that x equals 1 plus the probability that x equals 0. We would add those numbers together. Same way here. This is for the probability that x is greater than 1. Now here, if you notice, x being greater than 1 is equal to the probability that x is 2 plus the probability that x is 3. So that's 2 calculations. If we try to do 1 minus the probability that x is less than or equal to 1, we're still doing 2 calculations. So just for the heck of it, I went ahead and did the probability for x equals 0, 1, 2, and 3. Then I added 0 and 1, and I got this number. And then I added 2 and 3 and subtracted that from 1, and I still got that number. That really only worked because we only have 4 choices here.